In this video, we're going to make a simple character jump in 2D. The jump will be using Unity physics so we can easily implement a platforming level. Let's begin! Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. So this is what we want to make. We have this character here with some nice animations. I can press space to make him jump. And as you can see, the jump uses the Unity physics system, so he jumps up and gets pushed down by gravity. There are also 3 modes that we can apply to our jump. So for example, we can have our character have full control whilst the jump is in midair. We can also make it have no control whilst in the air, so if we jump, he keeps going on the same direction. And we can also set it to have some control in midair. So I jump to the right and then I can stop it for a bit. All of these various jump types are dependent on your game design. So we're going to create these 3 modes, and then it's up to you to figure out which mode best suits your game. Alright, so let's get to it. First, here is my starting scene with my character. All he has are some simple animations. There's no movement or jumping whatsoever. So let's see the simplest way to implement jumping. For that, let's first go into the player game object. And in here, in order to be able to use Unity physics, we're going to add a Rigidbody 2D. This is the main component that interacts with the physics system, and just by adding this we can already test to see those physics being applied. So let's run the code, and yep, there it is, the character starts falling along with gravity. Okay, so let's add a simple platform. For that we come here, we create an empty game object, call this the platform. Let's add a sprite renderer so we can see it. And here on the sprite renderer, without any texture, it's not visible, so let's add the white pixel texture. This texture is literally just a 1x1 white pixel, and by adding that we can now view the game object in our scene. So now let's stretch it to make our platform. Okay, so let's say this is the size that we want. Now let's add the box collider 2D component. And that's pretty much it for adding physics to a platform. This object now has a hitbox that will be used by the physics system. However, if we run the code, there's the character falling down, and yep, it goes through the platform. That's because our character also needs a hitbox. So let's go back into the character, and in here, add also a box collider 2D. Make sure that the hitbox size matches that of the sprite. Okay, now it should work. Let's see. There's the character falling down, and yep, there you go. He stops falling down once he hits the platform. Okay, great. So now we have our basic physics set up. Now let's make it so that our character can jump. Here on the character game object, I already have 2 scripts applied. The base script is what handles the animation, so don't worry about that one for now, since the animations are irrelevant regarding the jump system. So for that, let's open the player script. Okay, here we are. As you can see, it is pretty much empty. All it has is a reference to the player base component so we can play our animations. So in here, let's first listen to player input. So for that, we make a private void update. And now in order to listen to simple input, we simply do if input dot get key down, and let's test for keycode.space. So on the frame when we press the spacebar, this will be true. And when we do that, we want to jump. Now, in order to jump, we're going to change something in our rigid body. So let's go up here and make a reference for the Rigidbody 2D. So with our reference, we can now go in here and modify the rigidbody.velocity. Velocity is how fast the rigid body is moving, so by changing it directly, we will have a correct jump instead of adding force, which would be more gradual. So velocity takes a vector2. For our vector2, we want it to move up, so we do a vector2.up and then multiply it by a certain jump velocity. So let's do in here a float for the jump velocity, and then we multiply it in here. Okay, so that should do it. When we press our spacebar, we are modifying the velocity to make our character jump up. Let's see. Okay, there's the character sitting on the platform, and when I press space, yep, there you go. As you can see, it did indeed jump up and fall down. Now the jump feels a bit floaty, so we can play around with the values to get a nice jump feel. Here on the rigid body, we can modify the gravity scale. So by increasing it, we can make the jump much less floaty. Okay, so these values are obviously going to depend heavily on the scale of your sprites and your levels. But in this case, a gravity scale of 25 and a jump velocity of 100 makes for a nice jump. Here it is in the game, and if I jump, yep, I have a much better jump. It's much less floaty and much more accurate. Okay, great. In here, we can also go into the constraints in order to freeze our rotation so the character doesn't bounce around when you go to an edge. Now, one issue that we do have in here is that essentially we can keep jumping. So if I spam space, as you can see, he just keeps jumping non-stop, and essentially our character can fly. So that means we need to test when the character is on the ground, and only if the character is on the ground, then we can jump. So let's go into the code, and now in here, we only want to do this jump if our character is grounded. So in order to test if the character is grounded, we have several options depending on how we want our game to work. The simplest way possible is just with a simple raycast. So you do a raycast from the center pointing down and you test it. That works fine, but it only works on a perfect line, meaning if your character is on an edge, the center of the character will not be on top, so it will not count as being grounded. If you want your character to essentially occupy just one pixel, that would be a valid way. However, for our character, we're using a box collider, so we want it to occupy more than just a single point. So instead of a raycast, we're going to do a box cast. So let's go in here, make a private bool, call it isGrounded. And in here, we're going to go into the physics2D class and do a box cast. So we need an origin for our box, and the origin will be our box collider. So let's go up here and grab that reference, a reference to our box collider 2D. So we can use the box collider.bounds.center. So the center of the box collider is going to be our origin. For the size, we use the same size as our box collider. Now for the angle, we don't want the box to be rotated, so we just give it 0. And for the direction, we want to point down. So let's do a vector2.down. And we want to move down by just a tiny amount, just enough to check if there's something in there. So in here, we need to multiply by a certain distance amount. So in this case, let's say just 0.1f. This is just so that the box cast that we're doing is just slightly offset from where the player is sitting. Okay, so this is our function. And this box cast returns a raycast hit 2D. So raycast hit 2D. And then all we need to do is check if the raycast2d.collider, if it is different from null. If it is, then that means we hit something, so we are indeed grounded. So just for testing, let's do a debug.log to make sure we are hitting what we want. And here on update, we're only going to jump if our character is grounded, and we press the spacebar. Okay, that should do it. Now let's see. So here is the character on the platform. However, here in the log, you can see an issue. The raycast is hitting the player's hitbox. So essentially, we still have the same behavior where we can essentially jump since he's hitting the player hitbox, so he's constantly grounded. What we need is to ignore the player's hitbox and test for the platforms only. For that, we can use a layer. So we click here on layer, add the new layer. This will be the layer for our platforms. And now we go into our platform sprite and we set it to the platforms layer. Okay. And now we can go back into our code. And up here, let's add a field for a layer mask. So a private layer mask. This is essentially what describes which layers we want to hit with our raycast. We're going to set this in the editor, so let's make it a serialized field. Let's see how it looks in the editor. Here we are on the player. As you can see, there's the layer mask. We're going to set this to only hit on platforms. So our layer mask will only hit platforms. And now back in the code, let's rename this to platforms layer mask, just to make a better name. And down here, when we are checking if we are grounded, on this function, we can also pass in a layer mask. Okay, so that's pretty much it. So now this box cast will only hit things that are on the platform layer. So we can now go back and test and see if our ground code is now correctly working. And yep, here it is in the log. As you can see, it's no longer interacting with the player, but rather with the platform. So in here, I can press space, and yep, there you go, a normal jump. And if I spam space, yep, there you go, I can no longer fly. Now I can only jump when I'm touching the floor. All right, great. So we now have vertical jumping working perfectly fine. Now that we have that, let's deal with some movement whilst in the air. So before that, I'm going to write some quick, simple movement code. Okay, so here is the movement code. I want this video to be focused on jumping, so I won't go into too much detail, but let me know if you would like a video focused on various types of movement. So in here, all I'm doing is checking for the left and right arrow keys. When no key is pressed, then the Rigidbody.velocity simply stops. When I'm pressing left, I put the velocity on minus move speed and on right on plus move speed. So this makes our movement very snappy and controlled. So let's see it in action. So I can move to the left, move to the right, I can jump, and yep, there you go, I have full control over movement. Okay, now let's add our animations to make this all look much better. Okay, so here is the set animations code. We just check if we are grounded. If we are grounded and the velocity is 0, then we play the idle animation. If we are grounded and velocity is not 0, then we play the movement animation. And if we are not grounded, then we play the jump animation. So here they are, move left, move right, as you can see the animations, and jump, and yep, there you go, everything looks right. Okay, great. So with all of that working, now with regards to the jump, we can do several things. The way that it's currently implemented, we have full control whilst in midair. So in here I can jump to the right, then midair stop and come back. This is one way to do it. However, now let's say in your design you want the player to have no control whilst in midair. So let's go to the code. Here on the movement code, we're setting the velocity once the key is held down. So all we need to do is make sure that this code only runs when the character is grounded. So in here, in handling the movement, we simply do if is grounded, then we handle movement. If it is not grounded, then we do not handle movement. Okay, let's see. Okay, here we are moving, now I jump, and yep, there you go, I cannot change my direction once I'm in the middle of the air. So I can jump to the right, now I press left and it doesn't work, it only works when I fall down. So this is one possibility. Again, all of this depends on your design. Now let's check out another possible design. So let's say we want to have some control while in midair, but not exactly like on the floor. So let's first go back to the code where we had full control. Okay, here we are, and I have absolute full control whilst the character is in midair. Okay. And now in our handle movement code, we're going to do some different things in here. For example, when we are not pressing any keys, when we are grounded, if is grounded, then we're going to do exactly this. We're going to completely stop. But when we are not grounded, we're going to leave the velocity as it is. So if we'll let go of the keys, he keeps going on the same direction. Now when pressing left, if we are grounded, then we change the velocity exactly as previously. However, when not grounded, we're going to modify the velocity a bit to the left. So we modify the velocity, we don't change the y, and we change the x. Here, since we are running this on every frame, we need to multiply by time.delta. So essentially, when we are not grounded, we are constantly pushing the velocity to the left side. Now let's add also a variable to check our mid-air control. So we float mid-air control, and then we can play around with this value. And then let's make sure it is always within valid ranges. Okay, so we shift the velocity to the left side by a certain amount. Then we make sure that our rigidbody velocity.x stays within minus move speed and plus move speed, and we'll let go of the velocity.y. So all of this essentially means that we slow down while in mid-air. So let's see if this works. Okay, here we are. Now I jump to the right, and then I'm going to try to stop my jump. Jump and try to stop, and yep, there you go. I had some control, as you can see. If I go and just let go, he goes all the way in there. If I go and I stop, yep, there you go. I have some control in mid-air. Now we can increase this amount, but yep, that's exactly what we want. Now let's apply it to the other side. Okay, let's test. So here we are, jump to the right, and yep, I can control it slightly, and jump to the left, and I can also control it slightly. So I can, for example, jump, then I see I'm going to overshoot, and I can try to cancel it. Again, the values are easy to change, so if we want more, we can change it. So here, instead of mid-air control like that, let's put 3. So I go, I jump, and yep, there you go. I can almost change direction fully whilst in midair. So I jump and I can fall exactly on the same place. Jump in there and come back and I fell down. Okay, great. So as you can see, we have three possible rule sets. We can have full control while in midair, we can have no control or some control. Whichever you choose will depend on the design for your game. Now let's see one final problem that we have. First, let's add another platform to the side. And now let's revert back to being able to move in midair. Okay, so I have separated all the behaviors in three functions, so you can use which one best suits your game. So in here we have the full midair control, some midair control, and no midair control. So now let's use the full midair control. And now let's test how things work with this second platform. Okay, there's the second platform. I can go into it and yep, there you go. I can jump on top. Okay, everything seems nice. However, if I jump at an angle straight to it, there you go. The character is now stuck in midair. That is because I am holding down the right key, so he's constantly trying to move to the side, which stops his fall. So if I let go of the right key, there you go, he falls and works fine. So the issue in here is because of friction. So if I'm pushing to the right and he's causing friction, then that friction is keeping him whilst on midair. So for that, we can pause our scene. Here on our Rigidbody, we have a place where we can add a physics material. So we can create one. Let's go in here, create a new physics material. And we're going to call this no friction. And here all we need to do is set our friction to 0. Drag it onto our rigid body. Okay, and now let's test. Here we are, and if I jump at an angle, yep, there you go. He hugged the wall and kept moving up and then fall down. So as you can see, he no longer gets stuck if we hit the wall from the side. So there you have it. We created a simple jump using the Unity physics system. Using this as a base, we can now create any number of platforming games. We can easily do level design by creating multiple platforms and managing the player jump height. As always, you can download the project files and utilities from unitycodemonkey.com. If you liked the video, subscribe to the channel for more Unity tutorials. Post any questions you have in the comments and I'll do my best to answer them. Alright, see you next time!